Hey, greetings everyone. Nicholas Hancock here, CEO of Midwest Lightning Rods. We're a lightning protection company, specialized trade contractor in the electrical union right here in Local 146, which is in Decatur, Illinois. This is my fifth video. They're not in order by any means as far as importance if you are a new installer. However, I've had to make them as the importance came up. And currently, this video that I'm making today is going to be a kind of short video on basic code, which is, of course, there's some big code books, UL code book, UL96A is pretty substantial size. But I'm going to give you the things that we use every day on a regular, just to make it so if you are on site as a contractor, these things can probably stick in your head a little bit. Excuse me. Sorry. So we're going to go over a few basic terminology terms that we use in the industry and in the field, and then just basic code. I'm glancing over here. If you see me keep looking this way, because I have a cheat screen over here. Because if I don't have it, I'll just get to talking. Okay, so we're going to start with the terms. No, we're going to start with the code, and then we'll go back to the terms. Okay, basic code. So when you are installing a lightning protection components, they are strung together by interconnecting conductor cable. When the cable goes from one level to the next, or when it goes maybe up the side of a unit or over the edge of a roof, there's an important rule here. You are not allowed to have more than a 9-inch bend radius or a 45-degree bend. So what that means is, as much as it would seem like it would look better if you could just hammer that sucker right over the edge, you can't do it. We have to maintain a 9-inch bend radius. So that has to be kept in mind when you're going to connect from intersecting cables that are running perpendicular to each other. You want to make sure you leave room. If you don't T-splice, if you're going to use a double, then it has to curve into it. So leave extra 8-10 inches of cable to make that bend. Okay, the other thing is air terminal unit spacing. If you don't know what the components are that I'm talking about, there's a video on that. But air terminals, lightning rods, their spacing in general is within 2 foot from the roof's edge and a minimum of every 20 feet throughout the perimeter or throughout a ridge of a structure. So that means if you got a gable roof, you measure in no more than 2 foot to put your first air terminal unit. Now that spacing, of course, you could go all the way out to the end. Why not? Well, because how air terminal units are made, the cable goes through them. If it's coming out the other side and it's going to maintain our 9-inch bend, then we can't be all the way to the edge and still stay on the roof. So we usually come back 18 inches again. Let me stick to it. The code is you have to be within 24 inches of the roof edge. So when you come to a corner, if it has a really wide coping or parapet wall cap or whatever roof cap, if it's really wide, you have to make sure. I say on the corner because the corner is always extra long, and if you kind of try to stay on the inside of a 12-inch cap as you go around the roof, when you get to the corner, when you back it up a little bit, you have to make sure you're within 24 inches. So you should always be able to put where the air terminal is getting installed, run a tape out, set the tape on 24 inches where the air terminal gets screwed into, and you should be able to move it around, and you should be plenty good as far as within distance of 24 inches from the edge at all times. The other thing is, as cable is ran from air terminal to air terminal, or air terminal to ground, it is to be attached to the structure every 3 feet, every 36 inches. Inspectors do have a tape measure. So I think that's one of the biggest things that people get in a hurry with is, I've been doing it long enough that I know what 3 foot looks like. However, I don't think anyone's going to trip over it being 37 inches, but when 3 foot becomes 3.5, which becomes 4, that means you're going to be installing cable holders in between them. So what I did as a newbie years ago is Pops gave me a 3 foot string, and there was a piece of chalk on either end, and I would go and hold the chalk on one cable holder mark, stretch it out, mark the next one, stretch it out, mark it, and I would go mark the whole roof and then put my cable holders down. Again, some people step it. You just have to figure out what 3 foot is and go with it. Because I will tell you, getting the tape measure out between every cable holder will get you fired. And that's just because ain't nobody got time for that. If you're a contractor, you're going to figure out how to gauge what 36 inches is pretty quick in this trade. Which it's no problem. There's nothing to it. It's usually just a side shuffle. So, that being said, every 20 foot is an air terminal. Every 3 foot is the cable is fastened. And an average of every 100 foot around the building perimeter, the building footprint, regardless of if there's a gable roof and there's just one row of points down the middle, if the building, whatever the building footprint measures, every 100 foot you have to go to ground. So that being said, you could essentially have a structure a huge structure that comes up to one big point. And one lightning rod can require, if it spaces out and it's 100 foot by 100 foot or whatever, to take 4 or 5 grounds just for one lightning rod. This is true. It's every 100 foot on average, which location can be jugged with a little bit, but quantity can't be. So if it's 500 foot around the perimeter, there's got to be 5 grounds. If it's 510 foot around the perimeter, there's got to be 6 grounds. So there's that. 3 foot, 20 foot, 100 foot, and 24 inches. You have to stay within 24 inches of the edge. When you're running conductor cable, it has to maintain a horizontal or downward slope, which means if lightning protection, of course, if something runs down from a unit, then that means it runs up to it also. But how that goes is you can't run cable uphill as a path to ground. So all paths to ground, which I'll get there in a minute, but paths to ground, it refers to, matter of fact, this is one of our terms, so let's just cover it. Path to ground. It's just what it says. Lightning protection system's job is to provide the most direct path with least resistance to ground. When lightning strikes a structure, what it wants is to get to ground. It's going to choose the easiest method to get there. What we provide is the most direct path to ground. However, if it has to be a downward path, which kind of makes sense. So in saying that, if we're running cable and there is some decorative, or let's just say a chimney. Let's just say there's a square roof or a house roof. Let's say there's a gable roof, okay? And then there's a chimney in the middle of it, cupola in the middle of it, whatever. rather than running up to it, up, over, and down it, we run around it, and then we come down and connect to it, because we can't run uphill to get to the next ground. We have to stay. So if that reference made it make sense, then good. If not, then I don't know. That's what I got. Okay. Excuse me again. Going back to the cable holder installation every 3 foot, that's going to depend on what kind of cable holders we use. Will depend on what we're mounting to. Rubber roof, some stone that looks like it'll blow out. We try to, anytime we can, we try to adhesive mount everything, but if we can't, then however, there's no excuse of not mounting is what I'm getting at. Okay. Rooftop extremities. So when I talk about that, I mean whether it is a PVC waste pipe, whether it is a soil pipe, metal, steel, galvanized, whatever. Whether it's an antenna, satellite dish, guardrail, roof hatch, skylight, solar panel, AC unit, condenser unit, cooling tower, fan, exhaust hood. I'm probably going to miss some, but if you're getting what I'm saying, rooftop extremity is anything on the roof. So here's how it works. Pardon me. If we are installing lightning protection, we are creating a new high point of the structure. So if any roof extremity, if we put our air terminals, which are typically 12 or 18 inches, if we put them around the perimeter of that roof, and there is any roof extremity that sticks up taller, or that our air terminal unit is not at least 10 inches taller than, then, which is pretty much everything that gets mounted on a roof, honestly. It gets tied to the system. But anything that our air terminal does not exceed the height of by at least 10 inches, then we have to install lightning protection on that roof extremity. If it requires one air terminal unit and it is less than 16 feet away from the main conductor, then we only have to come off of the air terminal unit with one path to ground, or with one down lead, which is another one of our terms, a down lead. You'll hear reference a lot. Our path to ground is accomplished with a down lead, and that is a lead of wire that leads down. And that means you can lead down off of a unit, down off of a penthouse, down off of the building, whatever. But that's the reference, is the down lead is the cable running, the lead of cable that's running down. So, yeah, if the rooftop is over 24 inches big, which let's just say it's a round mushroom hood or AC unit or whatever. If you put your tape out and it's over 24 inches from corner to corner, end to end, side to side, in any way, shape, or form, it requires more than one air terminal unit. Now, whether it takes 2 or whether it takes 4, whether it takes 10, that'll be decided and probably laid out on a drawing beforehand. But the important key to the code part is, if there's more than one air terminal unit, it must have more than one path to ground. So another term here is dead ending. So what we call it when we run our cable and put it into a air terminal unit base, air terminal base, and we just cut off the other side, so it just goes to ground on one side, like I was just describing. If you have a rooftop extremity that is within 16 feet of the edge, you would stick an air terminal or screw an air terminal, whatever, right in the middle of that unit. Fasten that cable over to the edge. If it's 8, 10 feet, whatever, fasten it to the roof. And then that's it. Call it a day. You get over to the edge, you're good. You dead ended at the unit. Well, you can't run through multiple air terminal units and dead end. It has to only be one. That goes the same with a gable roof. I want you to picture this. If you're on a gable roof and there's a dormer that sticks out, if the dormer sticks out from the main ridge or a roof line, whether, but if a ridge sticks out longer than 16 feet on a gable roof, we now have to go to ground out there off of that dormer. If it's less than 16 feet, we can do what's called dead ending, which we can run it out and just stop. And the surge of lightning, if it's less than 16 feet, is said to, it will still travel back the distance to find the easiest path to ground. Apologize, man. It's crazy. Keep coughing. Okay. So if something is in that rule with having to bond to things that are taller than, or having to protect the extremities that are taller than within 10 inches of our air terminals, that's regardless of what it's made out of. It don't matter if it's made out of plastic, paper, rock, paper, or scissors. It can be made out of anything. We got to put a lightning rod on it. If it happens to move, then we have to put a lightning rod next to it, right next to it, that sticks up tall enough that it's 10 inches taller. So, there's that. Okay, so if it is a rooftop extremity that is not taller than our unit, does that mean it's covered? Sometimes. So here's how it goes. We have to bond to any metal body, any conductive body. So that puts the PVC pipe. If you see plastic coming through the roof and it's shorter than our points, you could disregard. But that's about it. I think plastic vent pipes is about as far as it's gone, as far as having stuff that's non-conductive on the roof. But yeah, so let's just say that there's a roof drain, which there's roof drains on every flat roof, or weep holes, or whatever. But this is specifically roof drain or metal soil pipe that's short. And if it's within 6 foot of our main conductor, which means if they put the drains 5 foot away from the edge of the parapet all the way around the roof every 50, 60 feet, then you have to bond any metal body within 6 foot to prevent side flash from a surge of lightning if it strikes. So what's that saying is on its way to direct path to ground, it will jump off. It can. So part of the code states that we have to prevent that possibility. So whether it be guttering, whether it be soil pipe, whether it be roof drain, again, roof hatch, guardrail, anything like that, anything metal that is within 6 foot of our conductor, we have to bond to it. That's just how it is. If it's plastic, it's safe. If it's metal, we got to protect it. Okay, so when another term is that I'm going to go over, I think this is the last one too, so I don't have to do it as I go. It's something that's called a cross run. So when I've been speaking about the perimeter of the structure a lot. So let's just say there's a building that's 500 feet by 500 feet, big flat roof. And we have cable running all the way around it, right? And we already know it's 2,000 feet around it, which means we have 20 grounds going in because 2,000 feet perimeter every 100 foot. So, cross runs. So what this is every 50 feet, if a structure is over 100 feet by 100 feet wide, you have to run cable from side to side every 50 feet to stay to code And because there has to be mid-roof air terminal units that are spaced out every 50 feet rather than 20 feet. So if you can picture it, there's points, lightning rods, every 20 feet around the perimeter of the structure. And then in the center of the structure, it looks like a grid of cable. Because every 50 foot, we have to run this way. And then every 50 foot, we have to run this way. So it's a bunch of intersections. And at each intersection, within 24 inches of it, there's an air terminal unit. So a cross run is the mid-roof cable. There's perimeter cable, there's mid-roof cable, and there's bonding cable. Bonding is the cable you use to go bond to the roof hatch, the bond to the drain, whatever. The mid-roof cable is the cable that you're running regardless of what's on the roof if the size requires it. If the roof size requires it. Another thing with the code is it doesn't matter what is spec'd, what the owner wants, what the president wants. It doesn't even matter what I want. If I said it doesn't even matter, like I'm more important than any of that. But if you're coming to work for me, I'm more important. So it doesn't matter. Nothing can supersede this. And that is you cannot mount dissimilar metals to each other without using a proper fitting. So, and this happens a lot, you get to a job and they spec'd copper and you have all copper equipment in the truck. And you get there and there's a metal roof cap going around the edge of the roof where you mount all the perimeter components. That's when you freeze right then, because unless it's copper, you can't mount to it. The only bimetal things that we can mount to, when I say bimetal, either that won't have no effect, is if it's steel, you can mount copper or aluminum to it, and there will be no reaction. And stone or concrete and rubber or plastic. But so rubber roof usually sounds like we can use copper, but just depends on if there's a roof cap, roof coping that's over 2 foot or that we have to mount to and all that good stuff, which again, most of that's already figured out. However, there's been times where we've shown up with the wrong stuff as a whole. And of course it gets charged back. And I mean, it's someone else's error. Because we try to do our best to bring up the problem before it ever happens. So if someone's adamant, then it's like, hey, man, we're going to come and bring what you want, but we're not installing it. So there we go. I think that's it that I wanted to go over, except for here's a very important part. Just like you people watching this are just learning about lightning protection piece by piece. If you just watch this and you don't know anything. But if you watched a few of these, what you have to keep in mind that is very, very important is that upon completion, there's going to be someone that is a maintenance supervisor or project manager, whoever it is not well versed in lightning protection. Pretty much guarantee that. What they are going up there to see is that what you are doing and installing matched the submittals that were submitted, which means if you can stick to the plan, then stick to the plan. If you have a reason if you deviate from the drawings that are supplied, then make sure you have a reason. And I would probably even suggest getting permission, approval, something. But aside from that, they're looking to see that it looks good. So if cable comes off a spool and it's flat and straight, they don't expect it to look like crap installed. Everything has to be visually appealing. And a lot of times people are not happy with an exposed down conductor running down the side of their building. They're going to be even more but they knew it was coming. They're going to be more unhappy if it looks like shit. So, your job as an installer as a contractor, as a tradesman, is to take pride in it, make it look good, get the level out, get the chalk line out, get the laser out, do whatever you need to do to make sure you're doing it correctly. It looks good. There's measuring points on every structure ever. So there's that. So here's what we got. We got the 9-inch bend radius. We got that we have to stay within. We got 20-foot spacing between air terminal units on a ridge or around the perimeter. We got 50-foot spacing around mid-roof air terminal units. We have cable that has to be secured no matter where it's at, bonding, down lead, perimeter, mid-roof, any of that has to be secured every 3 foot. Our path to ground and our down leads and our conductor cable, everything has to stay running at a horizontal or downward path. So if you can picture it, every time lightning, you have to picture that lightning can strike any air terminal. When it goes either direction to ground, if neither one of them are uphill, then you're good. If one of them is uphill, then you need to change it. If both of them are uphill, then you need to change it all. So conductive versus non-conductive extremities on the roof. It only matters if it's if it's shorter than the roof height or the roof parapet or whatever, because anything that's within 10 inches of the height of our air terminal unit must be protected. If it's a metal body, and if it's not taller, but if it's within 6 foot of the main conductor, no matter what it is, has to be connected. Down leads go to ground every 100 foot on average around a structure. Can't mount copper on aluminum, can't mount aluminum on copper. Which I say that because Galvalume is what makes up pretty much all steel roof caps. Has Galvalume in it, which is what makes it so pliable, and makes it be able to get it to look pretty. Even if it's painted, that paint coat isn't non-conductive coating. It's just paint. So we install aluminum on that, as well as standing seam roofs, unless it's copper, which you can tell copper. Every 100 foot. Okay, I don't think I covered this. When you're running exposed down leads on the outside of a building, down lead cable that runs from the roof down to the ground, the path to ground for a lightning protection system. It goes directly into the ground right next to the building, regardless of where the ground rod is. Well, the 72 inches up. So from grade level up 6 foot, we are covering that down lead in a non-conductive shielding, which is going to be PVC. And that is, so you're going to put basically what I say is put a 10-foot stick of PVC at the bottom of every down lead, and then you have to fasten that every 4 foot. So you got to fasten it on both within a foot of both ends, then twice in the middle, and call it a day. But you do have to put at least 72-inch guard on all exposed down leads. And again, they just need to be straight also. Cross runs are ran, or if a structure is over 100 foot wide, all metal bodies. I went over all that. Okay, so watch it, rewatch it, whatever, and go back and watch a different one if you need to. But there we go. That's some basic code for us. This is going to be an important one. So if you're coming to the job, make sure you try to watch this again or listen to it or something. Thanks for joining it. If you're happen to be here just by chance and you would need any lightning protection installation needs or design needs, please feel free to contact me. lightningstrikes-weprotect.com, or you can give me a call, 872-4676. Thank you, everyone. Be blessed.